Entropy is a measure of disorder. When you heat a solid, the particles vibrate more, the crystal structure breaks apart, it melts, and eventually it becomes a gas. With each step, the disorder increases, so entropy increases. The second law of thermodynamics says that the entropy of an isolated system increases over time. For any reaction, the change in enthalpy, the change in entropy, and the change in Gibbs free energy all follow the same pattern. You take the sum of the values for the products minus the sum of the values for the reactants. These three ideas connect through the key relationship. Gibbs free energy equals enthalpy minus temperature times entropy. This lets us predict spontaneity. If the enthalpy change is negative and the entropy change is positive, the reaction is always spontaneous. If enthalpy is negative and entropy is negative, the reaction is spontaneous at low temperature and not spontaneous at high temperature. If enthalpy is positive and entropy is positive, the reaction is not spontaneous at low temperature and becomes spontaneous at high temperature. If enthalpy is positive and entropy is negative, the reaction is never spontaneous. Example 1. We simply plug in the numbers for enthalpy, temperature, and entropy. Sometimes you need a unit conversion, especially for entropy. The result is the Gibbs free energy for that reaction. There is another important relationship. Standard Gibbs free energy equals negative RT times the natural log of K. Example 2. Plug in R, the temperature, and the equilibrium constant K. Here R must be 8.314 joules per mole Kelvin, not the gas constant used in gas law equations. Galvanic or voltaic cells are simply reactions that are naturally spontaneous. In the zinc anode, zinc metal loses 2 electrons and becomes zinc 2+. Negative ions from the salt bridge flow in to balance the charge. In the copper cathode, copper 2+ gains 2 electrons and becomes solid copper. Positive ions from the salt bridge flow in there to balance the charge. Electrons move from the anode to the cathode, creating a voltage. For electrochemistry, Gibbs free energy equals negative NF times the cell potential. Here, N is the number of moles of electrons transferred in the balanced reaction, and F is Faraday's constant.